Hey guys, welcome to Unit 10, Section 1. Today we're going to be talking about cross-section and Euler's formula. I know it looks like Euler's, but it's pronounced Euler's. So Unit 10 is going to be focused on three-dimensional figures. In Unit 9, we're focused on 2D polygons, and we're still going to be working with polygons for a lot of the different formulas that we're going to use on this one, but three-dimensional meaning it's kind of jump out. It has three different dimensions that we're going to talk about. So the first new word that you're going to hear is a polyhedron. It's a solid that is bounded by polygons with faces that enclose a single region of space. So on the left here, these are polyhedrons because their faces, the different sides, are made up of polygons. So no curves, nothing like that. It's all normal polygons. Like the top figure is a pyramid. It's made up of triangles, and then the base is a square. And then the second figure, this is called a rectangular prism. And we'll get into more specific details with those later on. Now on the right side, we have the non-polyhedrons. So the first one, this is a cone. Number 2 is a sphere, and number 3 is a cylinder. Again, we'll get into more specifics, but these have curves rather than just edges to them, so these are not polyhedrons. All right, and then the next part we're going to talk about is what is called a cross-section. It's the two-dimensional figure formed by the intersection of a plane and a solid. So this can be any type of three-dimensional figure, whether it's a polyhedron or not. The cross-section is, you want to imagine like a plane, so a flat piece of paper, you could think of it, intersecting a three-dimensional figure. And then what kind of shapes would we get? So the first one, notice that this plane here, it's like parallel to the bases of the cube. So if we were to take out this little section right here, we want to think about what would that cross section look like, and it would actually just be another square. Whereas if we look at the diagonal of the second one, so this cross section is actually going to be a rectangle, because it's going to be a little bit longer. It's going to be the diagonal of the square, so it's not going to be the same on both sides. And then the last part, imagine that we intersected the top and the bottom of the cube, but this top part is actually a little bit longer than the bottom piece, so this actually forms a trapezoid. So just with that one three-dimensional figure, that cube, intersecting it in different ways, we can create multiple shapes out of that. So the next part says, describe the shape formed by the intersection of the plane and the solid. The first one's pretty easy to see. Notice it's the plane intersecting the sphere. This just makes a circle, and you can see it here outlined. The interesting one here, though, is the cylinder. Notice we take that plane and we intersect the cylinder, and we actually get a polygon out of this. We end up getting a rectangle. It also kind of makes sense, though, because you're meeting at these sharp vertices, these points here, and it's going through creating a two-dimensional figure, and it has 4 points, so we know a rectangle has 4 different angles. And then the last one, imagine that we're going parallel to the base of this pyramid here, and the pyramid itself has a pentagonal shape. So this would create a pentagon. All right, just a couple more of these. So describe the shape formed. Again, with the pyramid, as long as you're intersecting parallel to the base, it's going to just copy the shape of the base. So here, we would just get another rectangle. This prism here is going to give us a pentagon again, because that's the same as the base. This one's interesting because we're intersecting a rectangular prism on this last one. But notice we're only intersecting 3 sides. So we have this, and this. So we get a triangle out of this one. So it does like the number of sides that you intersect is going to determine the shape or part of it. All right, so that's the cross sections. Really not too bad, just looking at the picture, imagining what you would get out of it if you were to slide a piece of paper through the object. The next part is some more vocab related to these polyhedrons. A face is any individual flat surface of a solid object. You've probably heard that word before. So the different sides, and you can have multiple faces. A vertex is a point where two or more line segments meet. So that's kind of like the corner points where these line segments are intersecting each other. And then the edge is a line segment where two faces meet. Now notice, if I think of, this is a cube, so I have 6 different faces. This would be an edge because it's where this one and this face here meet. So there's multiple edges as well. Now Euler's theorem states that the number of faces plus the number of vertices is equal to the number of edges plus 2. Kind of a weird theorem, but it does work, as we'll test with this first object. So this is a rectangular prism. First off, think about the number of faces. So we have 1, 2, 3, 4. So all of the rectangles, we have top, bottom, front, and back. And then we have the 2 side pieces. So there's a total of 6 faces. Vertices would be all of the corner points. So we have 1, 2, 3, 4, 5, 6, 7, 8. And then edges is where all of the faces intersect. We have 1, 2, 3, 4. Then we have 5, 6, 7, 8, 9, 10, 11, 12. So as you can see, there's quite a few edges in comparison to the other one. So if we were to substitute out these values, we would have 6 plus 8 is equal to 12 plus 2. 14 equals 14. Voila, it works. And we can use this formula to solve if we don't know the number of, say, faces, vertices, or edges. So this one tells us if a polyhedron has 5 faces and 8 edges, how many vertices does it have? Well, using that same formula, 5 plus faces plus vertices, which we don't know, that's what we're trying to solve for, is equal to 8 plus 2. So 5 plus vertices equals 10. Subtract 5. Vertices equals 10. So there's 10 vertices. This time, if a polyhedron has 6 faces and 8 vertices, so 6 plus 8, how many edges does it have? Well, then you know it would have to be E plus 2. Just remembering that edges plus 2, that's all you got to do. So we would subtract 2 from 14, and we would get 12. So there are 12 edges with this polyhedron. And that is the end of the notes for the first section.